Hello, everybody. Um, okay, this is our third lab lectures. In this set of lectures, I'm planning to explain how we can design priming experiments. So, as always, first of all, we talk about when we can use or priming experiments as discussed in the main course book, and then we introduce different types of priming experiments, and then we go through the procedure for each specific priming experiments. Okay, so let me just move to the slideshow. Okay, so when do we usually use priming experiments? So, as the book explains, priming experiments are mainly designed to explore how a certain group of words or structures are activated while speakers are exposed to another group of words or structures. So, imagine that, as you can see in this. Let's say diagram, as you can see, for example, if uh, language users are exposed to a word such as a street, uh, I mean, some other words might be activated in your brain. So when you hear the word street, uh, the words such as vehicle, car are activated in your brain. And then when the word car is activated in the brain, then some other words might be activated, such as truck or bus or ambulance. And then in the next layers, some other words such as fire engine will be activated, and then you can see how the network is built uh, between the words which are primed and the words which are activated. So we usually call the words which you are exposed to prime words. So prime words are the words that you see or hear or you are exposed to, and the words which are activated in the brain are usually called target words. So you should know these terminology when we use prime words and target words. Okay, so but this is not the only case. For example, sometimes the neighboring words which are close uh, to the priming words in orthography might be also activated. For example, imagine that you hear a word cat or you see the word cat, and then some close words in terms of orthography will be activated in the brain. For example, as you can see, the word car is very close to cat. The only difference is the final letter. So it will be activated. Some other words such as cart or cast, as you can see again, there is an extra grapheme in these words. So again, here you can see a completely different network of uh, activation. Uh, so the words might not be very close in meaning. They might be completely different in semantics, but they are very close in their orthography. So this is another model which has been proposed. Even we have another model which states that, okay, when you see or hear a priming word, uh, some neighboring words, some close word in terms of phonology will be activated in your brain. So imagine that you hear a word again, like cat, and then some other words in terms of phonology will be activated. The words such as pat, sat, rat, some minimal pairs, or even some words which are which have some functional morphemes at the end, like cats. apostrophe s, or cats plural s, or even rats. So again, you can see a completely different model here. The words might not be very close in terms of meaning. They might not be very close in terms of orthography or grapheme, but they are close in terms of phonology. Okay, to wrap up, the main idea of priming is that when you hear or see a priming word, it triggers the activation of some other words in your brain. And by priming experiment, we intend to investigate which words or which structures are activated in the brain when you are exposed to a certain group of words or let's say structures. Okay, so what are types of different priming experiments? So we have semantic priming and syntactic priming. We definitely know how to, we definitely learn how to build the CyclePy version of these two uh, important types of priming. We have some other types of priming: cross-modal priming, masked priming, and subliminal priming. But we will not go through the building CyclePy file for these types of priming. But you can do the practice. The protocol is same as semantic, similar to semantic and syntactic priming. There are some minor differences which you can easily deal with. Okay, let's start with semantic priming. So what is semantic priming? As I said, uh, exposure to a specific word, which is referred to as a prime, will activate some neighboring words which are close in meaning to the priming word. So the words which are activated, as I said before, are called target words, and the words which the speaker, the language user, is exposed to is referred to as priming words. So let's see how we can investigate which words have been activated in the brain. So one way is to show participants the prime word for a very limited time, so the timing is not very long, and then uh, immediately display either a related, unrelated, or non-word for a short period of time. So they see the prime word and for a short time, and then they see the target word. So the target word is either related, unrelated, or a non-word. And then they should decide whether the string they saw on the screen as a target word uh, is a word or non-word, and then we record their answers and measure the reaction time to respond. So the idea is that um, if the target word has been activated in the brain, it'll be easier for participants to decide whether the target word has been a word or non-word. But if it is not activated in the brain, then it takes longer for participants to choose word or non-word option on the screen. Okay, but the point is that both the priming and target words should be displayed for a short time on the screen. So, and then we will learn how to do that. So this is just one example. You should have a fixation cross at the center of the screen just to draw their attention to the center of the screen. And then the prime word will appear on the screen for a very short time. And then the target word will appear. So this target word, as you can see here, it is related to the prime word. So the prime word was nurse, the target word here is doctor, they are related. So it should take much faster for participants to decide whether it is a word or non-word. But in some cases, if it is unrelated, for example, imagine the word carpet, then it'll take longer for them to choose whether it is word or non-word. So uh, the idea is that you should uh, define some buttons on the keyboard in advance. For example, P and Q, A and L, the buttons which are far enough from each other, and then you should give instruction to participants. So as soon as they see the target word, then they should be able to press one of the buttons. Okay, so as you can see here, this is the algorithm. So we have fixation cross, we have the priming word, we have the uh, target word, either a related, unrelated, or a non-word, and then they should decide whether it is a word or a non-word. And this loop is it is they are within a loop. And so for our discussion, let's not include the non-words. Let's just include the related and unrelated words. But in real life, in real experiments, you can also include the non-words, which is not a big deal. But for now, please pause the recording and then think about this question. Uh, Guess about the number of routines that you must have in your CyclePy, and then think about the input file. How should it look, and how should we design that? What columns are necessary in the input file? And as I said, because we are measuring the response, the participants' reaction times, so don't forget, we shouldn't forget to store the correct responses in the Excel file and also participants' reaction times. So pause the recording for now, think about these questions, and then play back the lecture to see how we can do it in CyclePy. Okay, so let's see how we can, uh, let's say, build a semantic priming experiment in CyclePy. So let me just open my CyclePy file. All right. Okay, so here, as I said, the very first routine, I mean, aside from the instruction, is showing the fixation cross. So simply, we should add a text routine, text activity. So let's name it something informative, fixation cross, and then it starts from the 0. It remains on the screen for a very short time, maybe half a minute. So we do not change these. And then what should it display? Just a simple plus sign or cross sign, and it is constant for all trials. Let's click on the OK. So this is our first routine. So the next routine, and let's name it something informative, fixation cross, because the names should be unique, so I put an underscore between fixation and cross. Okay, so next routine, we should display the prime word. So let's insert new routine, prime, and then again prime underscore word. Let's insert it here. So again, it should be a text. So let's name it something informative, prime words. So it starts from the very beginning of the routine, and then how long it should remain on the screen. Let's say 1 second. You can change this value. You should remember that the perception threshold for the brain is 500 milliseconds. So anything below 500 milliseconds will not be perceived consciously by the brain. Which we will discuss in subliminal priming. But let's just uh, put it, fix it to 1 second. So the prime word will remain on the screen for 1 second. Let's not change these values, and then simply say nurse. So my prime word nurse will be displayed on the screen for 1 second. And now I need another routine, which is target word, to display on the screen. So in the target word, the very first thing is to uh, show the target word on the screen, which is a text activity. So I call it target word activity. So it starts from the 0. And again, we can change this value, but let's not change that duration. So let's leave it to 1 second on the screen. And then these values are not changing. And then you can simply say which word to appear on the screen, which is doctor, and then select OK. Okay, and then the next step is for participants to select either it is a word or non-word. So uh, one way to do that is to add a keyboard activity here. So let's say response. So participants should be able to press the key as soon as they see the target word. So if you remember, here we said that the target word will appear from the very beginning of the routine. So again, here the start time for pressing the buttons is from 0, and then the duration is based on the condition, because uh, we wait until they press one of the buttons, and then we should define the buttons. They are fixed, either P or Q, and they are constant. And then force end routine, it means that when they press the button, it should go through the next routine, and then definitely they should store the key. No difference, because there is only one key. They press one of the keys. There is no difference whether you choose last key or first key. But we have a correct answer. So in this case, because doctor was a word, so let's say Q. Q is on the left, so it is word, and then P is on the right, it is non-word. Okay, and then let's click on OK. All right. Now, this is the algorithm for only one trial, and then when you have uh, lots of other trials, you need to insert a loop here. Now, let's see how we can insert the loop. For insertion, you know that for insertion of the loop, you need to make an input file. So let's open an Excel file and see how we can build an input file for a semantic priming experiment. So here, the very first column is index, and then item number. So let's only design our Excel file with 5 simple items. Okay, So another column which I need is to define the prime words. So nurse, for example, cat, for example, bank, for example, apple, and for example, book. And then we need another column which is target words. So here I should define the target words. Here let's say doctor, and then for this one I can say tail. For this one I can say for example uh, um, for example child. For this one I can say a completely unrelated word, for example stove. And then for this one I can say pen. Okay, and then you should bear in mind that when you are defining the prime words and target words, you should control for a lot of factors. For example, the frequency of the words, the length of the words, uh, whether they have something in common in terms of orthography, in terms of phonemes. So you should, control for these factors. That's why it takes a lot of time to design good priming experiment, because you should think about your prime words and target words. But because it's just an example, we are not spending a lot of time on defining our prime words and target words. And here definitely I need to uh, define target type. By target type, I mean whether it was, for example, relevant or uh, or related. Let's say related or unrelated or non-word. So this is related, this is related, this is unrelated, this is unrelated, and this one is related. And then we need another column which is correct response. So in correct response you should mention which button is acceptable. Okay, so as you can see here, uh, you have only Q button as a correct response. So this is the place where you should add some non-words to your experiment. So you add your non-words here, and then sorry, you have your prime words and then you have non-words, and then here the correct response is P. So in this case, you are counterbalancing, and then you don't make participants press only one of the keys on your keyboard, because they might get used to that. They think that, okay, all of them are words, and let's just press Q button on the keyboard. So if you define some non-words as well, then they have to press P button for at least half of them, and then you mix them, and then you are sure that okay, they have not um, pressed the button in random. Okay, but for now let's leave it out. In the real experiment you can add that. So this is our let's say Excel file, input file. Let's save it. I will save it simply on the desktop, on my desktop. So let me call it loop. Of course, I have another file, replace it. Okay, and now let's come back to our CirclePy file. So now here I need a loop which starts from here and then ends here. So let's call it a loop with capital L, and then the loop type is sequential, and then nreps is 1, browse, desktop, loop 1, yeah, and then let's click on OK. So what other changes we have to do? So in fixation cross we don't need any change, but in prime word we need CirclePy to go to our Excel file. So instead of having a constant value here, I put a $sign which means that go to the Excel file and take the value under this column, which is prime words. Because here we have the same name. Okay, so let's just change the name into something new. For example, simply prime, and then here set every repeat. Okay, and then in target word we have the same thing, target, and then here $sign, which means go to the Excel file and grab the value, show the value under this column, which is target words, and then set every repeat. Okay, and then here in the keyboard section we will not change anything here except for the correct answer. So I say go to the Excel file, grab this column, correct response, and then yeah, and then compare the participant's response with the value in this column, and then let's click on OK. Yeah, so this is our file, the CirclePy file for semantic type experiment. So in our next lecture I will talk a little bit about syntactic structure, syntactic priming experiments. All right, so have a good day and good luck.